Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the marketing director here at the Academy. Here with us today, we have Jay Brady, a principal environmental engineer at Stanley Consultants, and John Cook, the water and resource recovery facility director for the City of Muscatine, Iowa. Jay and John will be discussing converting organic waste into clean water. Also joining us today is our AAEES president, Dr. David Vicari. Dr. Vicari will serve as the moderator today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Dr. Vicari and both speakers will address the questions at the end of the presentation. Before we get started, Dr. Vicari would like to say a few words. Go ahead, Dr. Vicari. How are you?
Marissa, thank you. And thanks everybody for joining us. This is a part of a major initiative for the Academy to expand our webinar offerings. An important role for the Academy is in continuing education for all our groups, for our board certified members, student members, member category members, and so on. So we're here to educate. We're here to help you with your professional growth. And I appreciate your being here for that purpose. So let me start by go forward with introducing the speakers for today's webinar. Jay Brady is Principal Environmental Engineer at Stanley Consultants. He was the prime consultant engineer on this particular project for over 6 years, providing design concepts and then eventually the final designs. He has a bachelor's degree in civil engineering and a master's degree in environmental engineering from the University of Iowa. He's a licensed professional engineer in Iowa, Illinois, and Wisconsin. John Cook is the Water and Resource Recovery Facility Director for the City of Muscatine, Iowa. He's a state of Iowa licensed grade 4 treatment operator. He has over 21 years of experience operating and managing water, wastewater, and industrial wastewater treatment facilities in Colorado, Wyoming, New Mexico, and Iowa. He's also the city's stormwater department director and is currently serving as the Iowa Water Environment Association's delegate to the Water Environment Federation. John is a graduate of Muscatine Community College and Iowa State University with degrees in business administration and journalism. Jay and John, you can go ahead and start your presentation now. Thank you.
Great, thank you. We'll hold on just a second here. We'll see if we can get this thing going. There we go. So we're going to talk about converting organic waste into liquid gold in Muscatine, Iowa. And thank you for joining us here today to hear us discuss this very unique project. It's been quite a joy to work with John in the City of Muscatine on this project, and we'd like to share it with you. Just a quick note here. Thanks to Stanley Consultants for helping sponsor this webinar, and see a little bit about Stanley Consultants. We've been in business for 100 years, focusing on environmental, energy, and infrastructure challenges for our communities. So I'm going to turn it over to John. We're going to try to get our video shut off here and just work without video. And John, take it away.
Hey, good morning, everybody. Yeah, this liquid gold thing is kind of funny. It was a bit of a surprise to hear it called that at first, but that's pretty agreeable to me, I guess. You know, we operate the water wastewater plant in Muscatine, and we had a little flare for our anaerobic digesters creating biogas. The flare was new in 2010. And we hadn't really had a flare on the old digesters for probably 20 years. They just kind of leaked off into the atmosphere. So when we fired it up, we saw the flame going there, and we said, well, what are we going to do with it now? And instead of just flaring it off, we decided we needed to do something else. Since we had a lot of organic waste in our community, particularly the ketchup packets that you see there, which started this whole thing. Muscatine, Iowa has the largest Heinz manufacturer for ketchup and things like this in the country, and they threw away thousands of these every day. So we decided we wanted to capture that and make more biogas so we could start an energy program. So we said, well, what are we going to do with this, stuff, and how are we going to convert this into energy, and how do we make more gas? Because little Muscatine really wasn't making enough gas to entice anybody to run an energy program. We didn't really have any money, particularly to do that. There weren't any grants involved. So we said we need to have more gas so that we have some private funds to come to have a program like this. So back in 2012 or so, renewable natural gas for vehicle fuel was all the rage, and that was going to save us all. And natural gas was going to be the cure for our climate woes and everything else like that. And so that was kind of where we were headed with it at first. We had a lot of things set up. We had a good frog program. We had some spare infrastructure that we could use. Our digesters were really lightly loaded. We were running 45 days on our digesters. So we thought we had lots of stuff. And the flaring just said, hey, we have a lot of opportunity here to do this, but we need more gas. So where do we find the fuel for our digesters? And it turns out food waste was a really key target for us here in the Midwest. It's particularly where we have a lot of food manufacturers and lots of organic waste and things going around. So we said, let's find that 40% of food that isn't eaten, and all that waste that's going into landfills, and take it into the plant and convert it. And there's some places that are doing it on the coasts, in New York, California, and different places like that. But not a lot was happening in the Midwest, so we had to kind of look around and find where we were going to get our new fuel for the digesters. So we kind of use the EPA's food recovery hierarchy, as you see here, and building our program that says, what do we do since we're only the fourth best option for this food waste? So when it says MARV up there, what's Churns Food Waste and Energy, that's actually the Muscatine Area Resource Recovery for Vehicles and Energy program that we started. It actually targets all three of those first before we get to the industrial side. But of course, we are focusing on that industrial side right now today. And that's kind of where we are since we discovered this massive amount of food waste that was out in our communities and in our region. So Muscatine is building our sustainability efforts here. We have a program where sustainability drives our programs in the right direction so that we link all of these three aspects of sustainability, people, planet, and prosperity, to really find those key projects. And the project that we did focuses in on that so well. I mean, it's just a perfect match for all of these things. And the community really embraced it. I went through about 4 iterations of city councils proposing this, telling them that it wasn't a guarantee of any kind. And they still said, we want to go for it. We want to be that kind of a community. So that really speaks to our level of appreciation for sustainability in our community. So there's lots of benefits to what this will bring, and this is how we kind of sold it to the council, of course. Diverting landfill space, which of course we're a regional facility, so we're not just saving landfill space in our own landfill, the Muscatine County landfill, but landfills around the region as well, where all this material was going. And of course, when you do that, you lower the emissions from those landfills. Even if they're gas capturing, they're generally pretty inefficient at doing that. So the more organic waste you could take out of a landfill, the better for methane emissions from them. Of course, this is a good service for our community since there's a lot of need for this and a lot of requests for this kind of service that wasn't being met. So, but of course, the biggest thing that we sold it to was to recoup the capital. There was money to be made here, a new revenue source for the city. And anytime you can find a revenue source that meets all these needs, you're really hitting on all cylinders here. So again, we first, when we first started looking at this, renewable natural gas was all the rage. The renewable energy credits that you could get for that were really touted as far as what you could get for it when you inject it into the pipeline. And There's huge advances in renewable natural gas and CNG vehicle engines. And that was kind of where everybody's thought we were going to be going. Of course, I think we've shifted from that a little bit. And so, but this is where we started. And once we figured out that vehicles were not going to be all natural gas, that they were actually going to be electric. And so we said, well, what are we going to do with our gas? Since we want to get it into vehicle fuel and energy, since that is how we generate the renewable energy credits for the revenue that we needed to generate in order to make this project worthwhile. So the natural gas, the CNG delivery mode was kind of pushed. And now we're kind of looking towards the microgrid scenario that you see here, where we can actually generate power, we could store it, and we could push it back into the utility grid that we have to realize what hopefully will become an e-RIN. If you know what the RINs are, renewable energy credits that you can sell on the open market. And they promise us that an electric RIN is coming. It's been available since 2007, but none have been issued by the EPA. But they are working towards doing that at this time. So hopefully that becomes a reality soon.
So part of the opportunity that John talks about is the existing digesters. And in the background here in the photo, you see the two newer digesters at the plant. They were constructed about 2012. They're about 938,900 gallons total volume. And their design solids retention time is 22.8 days. They receive a mixture of primary and thickened waste activated sludges, about 24,000 gallons per day average, and about a 37,000 gallon per day max month, at about 5% solids for those feedstocks. At the time of the initial studies, the city was taking in about 16,000 gallons per day of fog and high strength waste and kind of processing it through the liquid train, which is not really ideal for handling those concentrated feedstocks. And they were getting a gas yield about 56,000 cubic feet per day average, but there's a lot of variability. And this equates to about 14 cubic feet per pound of volatile solids destroyed. The facility also has 4 older idle digesters that are part of a conversion. This used to be a pure oxygen plant back in the 70s. In the 80s, the loads had gone away and they converted the pure oxygen plant to aerated activated sludge. And when they did that, because of the drop in loading, they were also able to idle a sizable part of the aeration basin and partition part of it into 4 square digesters. They do need rehabilitation work, but that's another 2 million gallons of potential digestion capacity available. So as we look at the plant itself, the energy use and the biogas production at the time, the 30,000 cubic feet per day average would meet the digestion, building, and process heating demand with a peak of about 80,000 cubic feet per day needed. This is equivalent to heating about 90 homes per year. And of course, in the winter, we have a lot of demand for the biogas for the process and digester building heating. But in the summer, then that demand drops way off. Everything's warmer. And so we accumulate quite a bit of gas during the summer months, and it's all flared off currently. Natural gas usage, you can kind of see there, 3650 therms average per month, but quite a peak of almost 8,000 therms per month. And, you know, pretty substantial cost at $3,300 per month. And 7,000 during peak winter months. And of course, that was back in the good old days when gas was, you know, below $3.50 a therm. Whereas it's I think it was $7.90 today on the spot market. Electricity, we're 325,000 kilowatts per hours per month. Electric use, that's about $15,000 in electric usage per month. Feedstocks. So when we start thinking about co-digestion and biogas generation, what kind of feedstocks can we bring in? We want concentrated, ideally liquid material free of debris. But the city also has a FOG program for their restaurants and delicatessens, bakeries, any place that uses a lot of fats, oils, and greases in cooking. And so they wanted to be sustainable and provide that service to their local restaurant establishments. And so that was one of the key targets for this program. And then liquid organic waste, that can be a number of different things. A lot of liquid waste from food processing, but also we get solid organic waste, as John was talking about, the ketchup bottles, ketchup packets. There's all kinds of organic material that is packaged that eventually is not used for its intended purpose, but it gets ended up in the landfill. Past prime vegetables, expired produce, expired canned goods from grocery stores, cafeteria waste from schools. These are all examples of organic materials that can be recovered and actually slurried and digested. So we look at the local potential. Of course, the fog haulers, we talk about the local industries such as Kraft Heinz that John mentioned, local businesses such as our grocery store chain in the areas. Hy-Vee is one of the big ones. Regional industries. And then we also, as John alluded to, we're thinking that we're going to use this for compressed natural gas for vehicles. So we're looking at how can we use that readily, and actually Ruan, a trucking company, has quite a fleet of compressed natural gas trucks that they would be a potential partner to participate in this. So we look at our feedstock sources and our potential usage or availability of capacity. You know, treatment sludge, we talked about that already, 37,000 gallons per day average. At the time of the initial studies, the organic solid waste, or the total organics, we'll just call it, was about 3,000 gallons per day. And then fog and available capacity that we would have to reach our full digestion capacity that's available in the two newer digesters is about 23,000 gallons per day. So we embarked with the city and a sub-consultant, Eco Engineers, on a biogas waste shed study. And that's looking at what kind of feedstocks, organic feedstocks, are available within a 60-mile radius. And that encompasses quite a number of industries, including ethanol and biodiesel industry, a lot of food manufacturing, as John talked about, and then the material that goes to the landfilling that we identify as organic. And so this kind of breaks up kind of some of the different sources. If we were able to capture and process all of the organic substrates that are within an hour of Muscatine, we could produce 4 million cubic feet of biogas a day, which would be 17,000 gallons of diesel equivalent per day. So obviously we're not going to capture and process all that, but it kind of gives you a sense of the scale of material that's out there. So as we embark on our study, then we looked at low, medium, and high scenarios, so we can kind of start looking at risk and risk reward possibilities. And this is just looking at, okay, feedstock coming in, how much could we capture, how much could we process, variability in biogas production, what kind of cubic feet per day of biogas could we produce. And so on the low end, we're looking at about 98,000 cubic feet per day, and at the high end, about 185,000 cubic feet per day. And the two red lines across the front of that graph at 133,000 and 167,000 cubic feet per day represent what the plant is currently achieving with the co-digestion and the organic feedstocks they're bringing in. So we, thinking in terms of vehicle fuel, again, we converted that to diesel gallon equivalents. And so this is 425 to almost 800 gallons per day, which doesn't seem like a lot until you start aggregating that over a year. And as you aggregate that over a year, that becomes some pretty significant amount of fuels at 150,000 to almost 300,000 gallons of diesel a year. We looked at a number of different ways of utilizing biogas at the facility. One was just direct piping that into the building furnaces, treating the gas and then piping it. And we'd have to put in some additional gas infrastructure, fairly low cost, low capital cost investment that way. A cogeneration of heat and electric power. This has been practiced at anaerobic digestion facilities across the country for many, many years. It's hard to make it all work number-wise from a capital and operational cost perspective. But when you start putting in these renewable energy credits, that starts paying down that capital cost and making it pretty attractive. As John indicated, now we're thinking about microgrid management and these ERINs, the electric power renewable energy credits that we hope to see come out of the EPA here soon. And then compressed natural gas for vehicle fuels, that was number 3. And, the concern there, of course, is we produce this gas, we have to store it for some period of time before it's put into vehicles for use. So how do you manage that inventory of compressed natural gas? And then the treated biogas, natural gas pipeline injection. That's a great option. It takes away some of the inventory management concerns. It allows you to maybe maximize your revenue from energy credits, but you have quite a high cost of connection. You have a lot of parameters you have to meet to assure the gas quality. And at the time of the study work, this utility gas specification by the local gas utilities was not really in existence. Since then, they've all come up with gas specifications for this type of project. So us being engineers, we ciphered the numbers, we estimated capital costs, we estimated annual costs, we savings and revenues, and kind of looked at a 10-year present worth cost. And out of these different ones, the compressed natural gas for fuels really was the one that would show a positive when all the numbers were assembled. So looking at the overall estimated cost, the phase 1 receiving facilities that we're really going to focus on today, that was estimated at $2.5 to $3 million. The phase 2 digestion renovation was $1.6 million, and then the bio CNG vehicle fueling facility that was estimated at $2.5 to $3 million. And then we have operating costs that we also estimated for the study work. For the phase 1 receiving, which is really the focus, we were looking at $60,000 to $90,000 a year in operational cost. And we look at potential revenues for the project. Tipping fees is an important aspect of this, and actually the phase 1 receiving facilities, our efforts looking at that from a return on investment standpoint was really focused on just funding out of tipping fees, because we weren't sure if and when the biogas utilization component would be capitalized and funded and then implemented. But then moving forward, if we take and use that biogas that we're producing, we have a fuel value. And then we also have these renewable energy credits. And basically that's petroleum producers are paying dollars to get these offset credits. It's a federal program, But then if you can get into the pipeline and that type of thing and call it transportation related, then you can get other states participating and kind of stack these credits, and can be a substantial revenue stream. Okay, so this is talking about tipping fee revenues. And so what we're looking at here is a low of about 230,000 to a high of 950,000 based on the volumes that were anticipated. And currently the plant, as of this last year, it was almost bringing in close to $500,000 a year in tipping fee revenue. So that's kind of right there at that medium category for the scenarios. This is just looking at the renewable credit dollars. We're not going to dwell on that a lot, but it does illustrate that there's some substantial dollars there. They are variable, which we will talk briefly about. And then fuel revenues, and we did two different approaches here. One is if we just used it as converted the city fleet, garbage trucks, and some of the other vehicles in the city fleet to natural gas, compressed biogas. And then also if we were able to sell to a fleet like Ruan, the trucking company that has a lot of gas-fired trucks. And so you can see that there's some pretty substantial revenues or fuel savings, depending how you characterize it, for the actual fuel value. And then we stack all that together, and you can see that the total revenues could be pretty substantial if the project was implemented to all three phases. The biogas was being beneficially reused, and we were getting renewable energy credits. So we kind of looked at, what kind of rate of return are we looking at? This municipality that's looking at this. So their timelines and time horizons are a little longer, but they don't want to end up investing in something where the equipment's going to wear out before they get some type of return. So we did a low, medium, and high, and really looking at phase 1 and 2 for the utilization. And as you can see, the high and the medium delivered under 10 years, which is kind of a marker that we're kind of shooting for. But even the low end, we're delivering in under 20 years, theoretically, before equipment would wear out. So I wanted to speak briefly about some of the risks that are associated with a project like this. And so we have to recognize that and consider that in our thinking. So one of the things is that maybe you don't capture the organic waste volumes that you thought you were going to capture. That hasn't been the case for Muscatine, but as competition perhaps blossoms, as other entities embark on this type of endeavor, there may be competition for that feedstock, that organic feedstock. So you could see lower volumes in the future. On the fuel side, for compressed natural gas vehicle fueling, what happens if we don't have the type of fuel consumption and sales that we were anticipating? And then our tipping fee rates are we set a tipping fee. It's kind of associated with the solid waste tipping fee, but if we have, again, competition from other facilities for these same feedstocks, perhaps our tipping fee rates would drop and that revenue would decline. And then the renewable energy credits, what is that value? That value fluctuates. It's a marketplace. Excuse me for a second. And that those values can be phased out. Also, it's a government program, so government programs do sometimes end. So there's some risk associated on fully relying on those RIN values. And then higher operating cost. Again, more labor, more equipment costs, more utility costs, what have you, could change the economic dynamic. So I'm going to turn back over to John. He's going to talk about some of the exploration part of our project.
So this is the fun part. When we started looking at all the food waste that was in the area, we said, well, what are we going to do with this? How do we get the ketchup out of the packet, as it were? And so we kind of started looking around. And I said, well, I had a guy there in the back that vended, it was had the Muffin Monster contract for Iowa. So I said, what, can you bring me a Muffin Monster? We're going to set it up sideways, and I'm going to start dumping stuff through it to see what happens. So we had it set up on an old pump pedestal there, and we started throwing things through it. We actually did end up putting several screens that we had on the bottom to see if we could capture that trash and organics come out the bottom. But these are the kind of things we did when we first started out, just to see what would happen and start exploring those alternatives and things that are going on. So, but of course, that's a pretty inefficient way to do it. But this is a very efficient way to do it with the turbo separator from Scott Equipment. There are several manufacturers of depackaging equipment out in the world. Most of them are made in Europe. This one actually happens to be made out of New Prague, Minnesota. So being in Iowa, we really liked that they were really close. They're a Midwest company, and they're an American company as well. So for parts and different things like that, we were really excited about having that opportunity. And I went and saw a few of these around the country. Saw one in San Diego, as far away as Pennsylvania as well, to see what their reactions were to these machines, and they were all very positive. So we went down that path, and that was the decision that was made for us because of the kind of material that we had mostly, and how we were going to process that. So this is what one of those looks like on the inside. If we look at the barrel part of it, it's basically just a hammer mill operation where you see the shaft with the paddles attached, and those paddles can be angled in certain directions depending on the product that you're running. You can change those. So if you want to keep the material in the machine longer, you angle them straight. If you want it to go through faster, you angle them more to get that desired result. But that's kind of how that works. And these will actually rotate at about 400 to 800 RPM. This is typical material that we get, canned products. So that's the cans as they show up at our plant. That's the material being dumped, the organic that was inside of the can. And then the can itself looks like it's kind of just a mangled piece of aluminum. It's not shredded. It's not chewed up, but it's just kind of mangled up a little bit there. But that's very recyclable material as well when it comes out in that form. So we try to do that as much as we possibly can, is recycle the packaging as well.
So as we explored and looked at model facilities, which there are very few of across countries, we started contemplating what it would look at here at the Muscatine Water and Resource Recovery Facility. Just wanted to kind of give you a little bit of orientation. The control building is labeled there on the right. The newer digesters are up at the top of the screen, circular white objects. And then you can kind of see the aeration basin and the old digester area there. We first conceptualized what we needed to do here to receive these organic wastes. We were looking at the area that is just south of the idle digesters, that proposed receiving facility. The initial thinking was, hey, we got a once through drive, two entrances, an entrance or an exit, and we could site it there, and everything would work great there. Have some area for some paving for backing into our tipping floor, and then want to take and manage this material so we don't disrupt our anaerobic digestion process. So we need to inventory our feedstocks. We need to homogenize it and meter it into the anaerobic digesters to minimize disruption of the digestion process itself. So this was kind of our initial layout. And we developed a receiving building concept here. This is just a rendering of what that looked like. Had a layout here where we took our liquid waste receiving from the trucks that were driving by there off the bottom of the page, hook in, discharge their load, go through a rock trap, bar screen, and get into a pump well basically below the turbo separator. That's the big circle, the pump well. And then we could pump out of that to another area of the plant for inventory management. And then the tipping floor there was where we were envisioning bringing this containerized organic waste in, the cafeteria waste, et cetera, to run it through the turbo separator. It's cutaway, kind of illustrating some of the facets of that building. And then in this here, this is the two feedstock inventory management tanks, high strength waste storage tanks, associated pumps and piping for keeping them warm, keeping them mixed, and then metering them into the digester. And some of the challenges of this project include the limited number of bottle facilities. John went and looked at quite a number of them across the country. There are very few that are actually doing decontainerizing. There's a lot of folks that are taking fog or taking liquid waste, but not very many that are doing the decontainerizing work that Muscatine is doing. Some of the concerns, of course, is the logistics and the trucking. If the truck folks, time is money for them. So they want to be able to get in to a facility, unload, and get out. And if you have lots of lines, trucks waiting in line, slow process to get unloaded, that type of thing, they might lose interest in your facility. And then how do you right size this? Well, how many trucks are we going to get of material a day? How are we going to stage that material? What size tank should we have? What is our peak truck traffic day versus average truck traffic? It's a lot to consider that way. And then for those of you that have been involved with fog and fog processing from grease trap programs, it's really interesting how much debris actually makes it down the drain in the kitchens. It's just silverware, cutlery, crockery, straws, rags, towels, you name it, it seems to find its way into those grease traps. And then again, homogenizing these feedstocks, managing that liquid inventory, and then feeding to our digesters in a constant fashion to minimize digester upset. And then at the site itself, we have some high groundwater issues and some geotechnical soil conditions that kind of drive cost at this particular facility. So we kind of changed some things around with our initial concepts. We had a high estimated cost for that. We had, again, some of these concerns about how can we handle truck traffic, what happens if we need to expand some utilities in the area. And so as a result, we ended up changing the location. We eliminated the new storage tanks and repurposed an idle tank on site, and then looked at using existing storage building. We went through that iteration, and again, costs remained high, so we reduced scale some more. We looked at manual screening. We looked at unused solid waste transfer and recycling center. In fact, we actually went out for bids, and the cost came back higher for that reiterated concept. And so we were really looking to see how can we make this work within our budgets. And fortunately, city staff identified unused space at the solid waste transfer and recycling center. And that has really been a silver bullet, silver lining to the clouds, I guess, so to speak, for us, because it's ideally suited. Here's the transfer station itself, and on the left-hand side where that MORC sign is there, that orange sign, that's actually the recycling portion of this facility, and it's ideally situated. We have loading docks here on the left-hand side of the picture where we can bring containerized organic waste in. We have a drive-through bay there at the top of the screen so we can bring our liquid haul trucks in. And this is how we orientated and organized this for the city, with the turbo separator there in the middle, and then a tipping floor with a push wall so that they could bring in like cafeteria waste and other types of waste where it's easier just to dump it and scoop it into that auger there that's at the middle of the screen and auger it up into the turbo separator. So this is just a quick little schematic of the process. We get our material in by truck, we put it into the feed hopper, it goes up the conveyor into the separator, and then we have our residual materials that come out in a residual auger that ends up in a bin or a dumpster. And the liquid gold, the organic goo, as I like to call it, comes out and drops into this receiving tote. And we can do some screening there if need be. We pump out of that tote into tanker trucks to haul over to the water and resource recovery facility. And here's a picture of the turbo separator setup, and I'm going to turn it back over to John.
Yeah, so this is how we orientated this machine. You can do it many different ways. It doesn't have to be set up in this fashion, but this worked out best for us as far as the loading and the trash receiving and everything. Yeah, we can go next. So this is kind of an example of some of the material that we have showing up in the upper left-hand corner. All those tiny cans are little cans of Vienna sausage that's made by a local manufacturer not too far from here. They send them to us, they don't even have a label on them. They just kind of separate it out by a hardwood flat, and then our staff dumps them on the floor, and we use our end loader to scoop them up and run them through the machine. So those are one of those opportunities where we have to actually capture the packaging for recycling as well. It's really kind of a neat concept. Below that, you see is the lunch meat that you've probably seen in here, local grocery stores. We have a large Oscar Mayer plant just north of us as well that makes all this shaved meat. It ends up sitting in a warehouse too long, or they found something wrong with it in quality control and they can't sell it. It can't be used for human consumption. So they bring it to us, and you can see the machine. That's after it's been depackaged. And that packaging is not destroyed at all. It's just kind of opened up, and the meat has come out, and the machine really works excellently with material like that. Next to that is dog food. We have several large pet food manufacturers in the area as well. And they get stuff that's wrong with that material. I don't know, they find metal in some of the batches, and so they just say, hey, we can't sell any of this to protect the pets. So they say it's better for us just to take out entire yards of this stuff, and we end up with truckloads of palletized and packaged dog food and other snacks. Now, above that, those pink and blue squiggly things, those are tubes. They're about 10 feet long, and they contain meat that goes into Lunchables. So they would actually feed those into a machine. They would slice them up and stick them in, and they're that kind of cracker-shaped meat tubes that we get. And believe it or not, the machine really takes those excellently as well. It just works beautifully on that. The plastic sheath on the outside comes out the trash, and the meat comes out the bottom, and it works and very efficiently to take care of those products.
Now, John, these are materials that are off spec. Sometimes they're culled from manufacturing. These manufacturers lots of times don't want to have that out onto the market. These things shouldn't be getting into the hands of the public. How do you deal with that?
We have a secure location. So our facility, of course, is locked. We have lots of signs saying that this is not material that is available for anybody to take. And we have lots of cameras. So we have a security camera system that's recording in multiple locations at all times. And that the recording is available to the manufacturers as well. So they can come and take a look at that at any time. Most of the manufacturers do send the USDA down at least for a few days to watch the operation, to see the trucks show up, and to watch how we handle processing it through to make sure that this material is actually being destroyed and not resold or taken home or anything like that.
Now you can actually certify to the manufacturers back that you destroyed it.
Right. So most manufacturers require a certificate of destruction, either their own or something that we have for them. And they will certify with the driver and with us, and we send that back to them. A lot of the trucks are locked. They have one of those actual, you have to break the seal to open the trucks to make sure the drivers of the trucks are not stopping somewhere and unloading this material as well. So there are a lot of safety measures that these manufacturers take to make sure that the product that they are sending to be destroyed is actually destroyed and not sold or taken home by somebody. So here's a little video showing how the material really works through the machine. It's kind of a fascinating procedure. This was one of our first weeks in operation. So our forklift operator here, or lift operator here, is going really, really carefully and slow. These guys work much quicker now than they did when they first started, because this is all kind of new for everybody. Nobody really knows how this was going to work or how it actually operates. But we found the equipment that we needed. We found the rotating fork mechanisms and everything else like that we needed to facilitate getting that material up and into that hopper. And it's kind of some unique stuff that is out there for that. The telescoping arm on the end loader was really key for us as well, instead of just a straight end loader, so that we can maneuver that around to grab other things and use it actually as a platform to work on the machine as well. So there was a lot of advantages to that. So that's milk that came from Costco. It actually was still all palletized. We dump it straight into the hopper. To twin augers take that product up into the machine, and then the paddles break open the boxes and the gallon jugs that are inside of the boxes. You see the milk coming out the bottom, and it's then pumped out of that tote and into the truck using a piston pump that's setting right back behind there. And then the trash has another auger, a single auger, that actually lifts that trash up so that you can dump it into a waste container here, which we then will take directly over to the transfer station, which is in the building right next door, which has been an incredible advantage for us as well. Is that the trash transfer is very seamless and easy, because that is one of the biggest things that we found, is that you end up with lots and lots of trash in a single day. And without having that advantage of being able to consistently remove that trash and bring back new bins, we would quickly fill up with lots of roll-off dumpsters and things like that.
Yeah, I think the debris quantities have been quite amazing.
Debris quantities were not they were much larger than what we'd expected.
So going over to the water and resource recovery facility, this is just illustrating the scaled down receiving facility that we had envisioned, that we ended up even doing away with this for our budget purposes. But here, just showing some of the things you have to think about: metering this material, running it through bar screen, the pumping, staging, how that is all done. And then at the treatment plant, here's kind of the process where we have our trucked liquid food waste, high strength waste coming in. It goes through bar screen, goes into a storage tank where we have jet mixing for that. And then it's transferred to the digesters, where we meter it into the digesters in a controlled rate. Here at this facility, we have receiving in the upper right-hand corner. And what we have there is John's and his plant staff's. I think they're going to patent it. It's their own receiving facility that they created for something very simple. It allows the trucks, like in the photo to the lower right, to back up, connect their hose up, discharge into this, and then it just drops through manual bar screen down into that channel, and then gets transferred into the storage tank. And the beauty of this is that John has the truck drivers actually patrol that bar screen, so they get up there and rake any debris out of there, so that they don't have the next guy doesn't have a problem. what it does, it also makes those drivers think a little bit about what they're taking and bringing to this facility. So you're not getting these just debris laden loads of material coming in. And then the lower left, you see the skid loader there dumping some material through a hatch into the storage tank. And that was original to the design. The storage bin area that they set up is not. That's something that the plant staff came up with. And that's for handling loose, drier types of organic material where we don't need to run it through the turbo separator. It's not containerized. So bins of dog food are an example where they're not bagged. You can drop that into the storage facility, and then they can drop it through the hatch into the tank and add some additional water if needed to slurry that up. So this is the storage tank that we repurposed. Had a different use at a different time and had gotten quite corroded over the years. It was sitting idle. So one of the things to put that back into service was renovating this corroded tank. So there's quite a bit of work in cleaning out. There was some material in there, cleaned out the tank. Then we had to refurbish the concrete that was corroded along with some of that rebar. So here's the end result in the middle photo there. You can see the gray coating. That's the refurbished concrete. The jet mixing piping and nozzles are on the floor of the tank. And then the lower right hand, you see our pumps for both jet mixing and then transfer. So John?
So one of the big things, of course, we wanted to do was make this a community project. So we have opened up a free drop site for organic wastes, and there's the green light, red light sign behind the lady there dropping off that explains what can and cannot be accepted. Basically, we're going to take anything that people would eat, and that's kind of how we describe it. If it's a bare steak bone that doesn't have any meat on it, we don't want it because there's no organic component to that. So that'll be on the other side. We don't want paper. We don't want compostables. We don't want dead animals. We don't want animal waste. We don't want corn husks. Anything else like that we can take, we do. And we fill that thing about sometimes twice a week, especially in the summer months when people have a lot of produce of their own and everything comes in. And we really feel this has been pretty successful without hardly any marketing at all. This has all been word of mouth. A few things in some papers and things like that, but people don't read papers much anymore. So this really has come about just organically, no pun intended, to within our community. So it's been kind of neat to see. We also have a company, this Green RU truck actually goes around and collects organic waste from several regional Hy-Vee grocery stores and things of that nature. So they've increased the amount that they can throw away. Back in the day, you had to have just an apple or a tomato or things like that were compostable, nothing with any packaging. Now they can throw away that bagged lettuce that turns brown and nobody's going to buy it, so they have to throw it. They used to just throw it in trash. Now they can bring it to us because our machine will actually get that out of the bag. And we expected about 5 big clients. We've ended up with about 10, and now I could say honestly we probably have about 12 large clients. And these large companies that manage them has been really the biggest boon to us. They have companies that actually do their recycling for them. That way you find one marketing or management company and they have multiple clients that can bring material to us. So that's been really the biggest thing that we've found worked to bring more material to the facility.
Okay, so just kind of running through some numbers. Again, this is kind of from the study phase, but also real results. So in terms of tonnage, in 2020, we started up about May, right? In 2020.
Correct.
And that partial year, the plant brought in about 1,600 tons that year. In 2021, they brought in 27, almost 2,800 tons. And then the goal is 4,000 tons a year. So we're steadily building towards that. In 2020, we had 3.3 million gallons of high strength waste that was processed. In 2021, that's gone up quite a bit to 4.1 million, with a goal of about 4.5 million gallons a year.
At current digester capacity.
At the current, yes. If we get our idle digesters up and rehabbed and going, we can bring in quite a bit more. So high strength waste revenues right now, this is just tipping revenue. And what we're seeing in 2020 partial year, about $280,000 in tipping revenue. We're just under $500,000 for 2021, and our goal is $500,000 plus, I would say. The high strength waste tipping fee started at $40 a ton. And that was kind of thinking about trying competition with other solid waste landfills, and then, what some comparable facilities are charging on the coast. We started at 40 kind of as an introductory rate, I would say. That's gone up to $45 a ton in 2021. And ideally, we'd like to see it get up to about 75. But reality is it's probably going to be more like 60 by the time it's all said and done with our tipping fee rates. Again, competition could rear up and hold those rates at a lower rate. So some of the operational tidbits here for receiving facilities. You really have to think about this truck queuing and circulation, how you're going to move these big vehicles around your site. The receiving volume, how much are you actually going to get? Debris removal, that's an important aspect of that, especially if you're taking fog and some of those other debris laden streams. And then some people don't necessarily think about this too much, but how do you interface with the haulers? How do you bill? How you administer that program? Weighing the material. We're very fortunate at the recycling center. We have an existing scale that we can use to weigh in and weigh out, so we know what the quantities and weights are. And then, where you introduce these materials into your liquid treatment train or your solids treatment train. And then I'll just put a caveat, you need to kind of be aware of anti-degradation. At Muscatine, we have a somewhat unique system where we don't bring a lot of liquid decant water back. The solids get land applied, they go to lagoons, and while we bring some water back, we don't bring that much back, relatively speaking. And so, but if you, in a different situation, you might bring quite a bit of ammonia and other loading back from dewatering or from other aspects of solids processing that could impact your loading and may be a trigger for anti-degradation. John, you want to talk a little bit about the depackaging keys?
Yeah, well, this was just kind of a trial and error. We didn't have any way of actually knowing what we're going to need, but we do have 2 full-time staff that run the Muscatine Organic Recycling Center, or the MORC, as we call it. It can be run by one person. They can be loading the machine. They can be taking the trash away. It's a little harder because we have to now drive that truck down to the wastewater plant, which is only about a block away, but it still takes, it's downtime for the machine. I have to unload the truck and then bring it back. But I would say staging is the biggest key to this, having lots and lots and lots of storage space. That was the big thing that, boy, I'm sure glad that first and second iteration didn't work, because we were not planning well enough for the storage that we would need for this and the amount of material that has shown up. So that's been a pretty important part of that for us. The packaging volume as well. This stuff looks like it's going to compact really well, but it's not. It fluffs up a lot. It's now open, kind of sits on top of each other. So you would end up with roll-offs everywhere if we didn't have the ability to just take this directly over to the transfer station and dump it on the floor. And the different kinds of pumps that we use are definitely different than what we've seen in typical wastewater that we always, think we are going to use. We have these piston pumps that we're now thinking of moving out into centrifugal pumps, or I'm sorry, peristaltic pumps, to move that liquid slurry around a lot better. So, and then the dry product challenges are really big too. You have to have a lot of water because dog food powder does not pump very well. You have to kind of really mix it up into a slurry. So lots of hot water as well, because stuff gets greasy. So there's lots of different things that we found that we needed that we weren't, didn't really know before. Of course, the material it can be a very abrasive. You can have all kinds of things that come in. You can have people that throw things in the bins behind Hy-Vee that they didn't know was there. That can really ruin your machine. You have to balance the amount of stuff that you bring in, and this was really difficult for us to initially do. We had to find out, hey, how do we balance the amount of proteins and fats and other things? So we've kind of have a nice balance now. We know we can't feed straight dog food. We know we can't feed straight dairy. So we stage that inside of our building, and we say, okay, we're going to run a little bit of this, a little bit of that, send that over on that day so that we don't overload our digesters. And figuring that out was just kind of trial and error as well.
I think this table just kind of illustrates, the variability of these types of feedstocks. OLR is organic loading rate. And you can see from these different feedstocks, that's pretty variable. The methane yields are quite variable also. It's just kind of illustrating that. And, the key is we want to avoid rapid bulk liquid expansion. And people say, well, what's that? Well, that's rapid gas production inside your digester that actually lifts your bulk liquid up. Some people call that foaming, but this is beyond traditional foaming. This is actually really expanding that liquid volume, and you get material coming out of the tanks, and this is what we're trying to avoid.
It's just kind of a fun picture. We're trying to have fun with it. Some work from work t-shirts that we're all wearing. And it's been a really neat opportunity to do this, and people have taken on to this. We've had people visit from all over the country now to come see how we got this thing up and running, and the public has been really happy with the results that we've had.
Sure, and I think we'll also close out a little bit with some numbers. The capital cost actually was $1.8 million in construction. You add a couple $100,000 in engineering services on top of that, and then some refurbishment that was outside of the construction contract of the recycling bay that needed some cleaning, needed some light change out, and some other things done to it to really make it work well. And then various pieces of equipment, forklifts, et cetera, added quite a bit. So the total project cost actually was $3.2 million in total by the time you add all that up. And then from an operational standpoint, I think you remember perhaps that we estimated $60,000 to $90,000 annual operating cost. The reality of it is it's more like 350,000, 400,000. We're netting about 150,000, 130 to 150,000 dollars a year right now, based on $500,000 worth of revenue. So between wear and tear, between labor and some of the other things that have to come out of the revenue stream, that's kind of some accounting for you. So the next phase would be to get one or more of these idle digesters renovated. We're looking at plug flow digestion. DVO is one of the vendors here. And we've kind of taken a pause on that as we look at overall capital needs across the city's wastewater program. But we hope to get on that bicycle very soon and get this one of the idle digesters renovated and providing additional ability to take feedstocks to meet this quite amazing demand. So I think that's our presentation, and I think David could kind of
Yeah.
steer us with question and answer. That'd be great.
All right. Thank you very much. That was really interesting. And I love the Mork from Ork connection. I think I saw on Facebook that just this week is some anniversary, maybe 50 years or whatever, when that TV show came out. So only some of the older attendees here are going to understand that reference, I guess. Robin Williams was introduced to the world by that TV show. So great. So let me go through some of the questions that we received here. I think you responded to somebody. Were you looking at these when you mentioned about the ammonia being linked to the protein content? Let me see what happens if I click the answer live here.
We can just answer them if you like. I can read them.
Sure. All right. How are you handling digestate treatment, particularly mitigation of high ammonia levels in the digestate?
Yeah, I guess the first thing is we haven't really had ammonia reach the levels of toxicity that I'm aware of in the digestion process, and so it's really orientated towards, as John alluded to in the presentation, the recipe, right? The mix and match the different feedstocks. John, you want to?
Yeah, the high strength waste doesn't actually have a lot of the ammonia in it. That we're not seeing that toxic level. The return, once we concentrate the digestate material and return water that we've decanted out of it, then we see high ammonia level that come back into the front of the plant. But otherwise, we don't have that issue in the digesters themselves.
Has that affected your effluent quality, or are you doing nitrogen removal or nitrification in your wastewater treatment plant, or what happens?
We do we don't have really a program for that, but we know how to do it, so we do it very well. We actually take out all the ammonia, but we do end up denitrifying a little bit in our finals this year. We have seen that. We haven't seen that in the past, but this year we did. So we're addressing that issue now to find out how we could better denitrify in the aeration basins.
All right, great. Okay. One attendee just wanted a confirmation. You said that I recall hearing that you said the speed of this turbo separator was about 480 RPM. Is that right?
400 to 800. Yeah. I mean, you can really spin this thing fast.
Yeah, that was like, I think his response was, wow, that's incredibly fast.
Yeah, it's on a VFD, so we can actually adjust that up and down as we need to. You can turn it down from that as well, but the material tends to just sit and roll around in there if you do it too slowly. So,
okay.
And
you mentioned your staff is two people on it. This is just run one shift, single shifts a day.
We run one shift at the morgue right now, and that's two full-time staff. At the treatment plant, we have 20 staff. That includes operators, lab staff, and maintenance personnel.
Okay. Dale Gable, looks like he's a friend of yours. He says, hi, Jay. And then he said, you presented volumes of the HSW that were considered to be added to the digester. However, did you evaluate the volatile solids or COD ratios of this material to your treatment plant solids in the total feed? I'm not sure exactly what he's getting at here. Do you understand that?
Yeah, we really looked mostly at the volatile solids loading rate, the organic loading rate. That's the parameter that's commonly used. And in Iowa, we have quite I guess what I would say, a little bit more archaic loading criteria of about 0.08 pounds of volatile solids per cubic foot per day. And with co-digestion, some of the studies have indicated that you can go up to about 0.35, which is a little bit maybe beyond where we want to be. In working with the Iowa Department of Natural Resources and looking at all the literature, we kind of established a 0.18 loading rate that we were going to try to limit the addition to the digestion to meet, to keep a satisfactory process going. I think at times during peak weeks and stuff, sometimes that gets exceeded. As you get a higher loading rate like that, you I think run a higher risk of having digester upsets.
Okay. Jim asks about crushed aluminum cans being a possible revenue source, and I'll make this maybe a little more general. Any possibility of doing some recycling with the solids coming out of the crusher?
Yeah, of course, if the aluminum or steel or whatever it is comes out clean enough, then the metal recyclers will take it and we will get some money for it. It's not something that I generally consider as, I'm going to count on that money coming in. So I don't, we make maybe a few $1,000s a year out of that, maybe $10,000 a year on that. So it's not really something I can count on. The other material some of it does go to an incinerator, but that's directed by the vendor themselves who wanted that done. So we actually have a roll-off dumpster out back. When we process their material, we take all the packaging and throw it in that dumpster, and they come and take it so that it can be taken away to an incinerator. The rest of the material, we'd sure like to have the labor available to debox this material first. And I know there's a facility that the one in Pennsylvania does do that. They take everything out of the cardboard boxes and throw it on the floor to be then put in the machine. That way they can recycle the cardboard. So,
yeah.
Oh, there's another question down there. So you process the packaged goods. How do you deal with cardboard boxes? So yeah, that's kind of where we're at on that. If we can, that goes down to a question down below. If we can do something with it in the future, we'd sure like to. A lot of these plastics that the manufacturers use, unfortunately, are pretty low grade. That's really where this needs to happen. And it needs to happen at the manufacturing level to say, we're committed to using a very highly recyclable packaging product, because the stuff we're getting right now, most recyclers don't even want.
I have a related question. Do you ever rinse off the solids as they're coming out up that screw conveyor and try to capture more of the organics or reduce the organics going to the landfill?
Yeah, if you saw those packages, they are completely clean, most of them. I mean, it really does a good job. The biggest thing that we do find is that we have a lot of pass through of some lighter materials, the dog food. You'll end up with that passing straight through the machine. It's just kind of the nature of the machine. That stuff gets whirling around in there. It's kind of hard to keep it all out. We have run material through twice. So sometimes we take the packaging bin where we've collected all the packaging and we put it back through the machine and we run it again. And that way we do collect some more organics out of that product. Yeah.
Oh, okay. All right. What kind of mixers are in your digesters?
We have OTI draft tube mixers. Two per digester. Yeah.
Right, and I saw you had those jet mixers in the new renovation.
Yeah, and those are Vaughan jet mixers attached to a Vaughan chopper pump.
What do you do for process monitoring? I guess in the digesters, volatile acids, alkalinity.
Yeah, we do most of that. One of the unique things that we found that they do in Europe is called a phosphatic, which is actually kind of the same alkalinity to fatty acid ratios, but that's a ratio that they use. It's a number that we kind of try to stick with. It seems to work most of the time. But we've found with everything that everybody says that here's a perfectly stable digester, everything should be running completely smooth, and the thing's foaming over or blowing up on us. So it's kind of hard to tell. Sometimes it's more or less an art than a science sometimes. But yeah, we do monitor all those and make sure that we're staying within those parameters, just so we're kind of catching ourselves if we get over on top of that.
Yeah, I remember looking at that ratio when I worked in the plant. So that's done in the
OSTAC? Yeah.
Yeah. Did the cost analysis account for debris from deep packaging? And if yes, how much per year? So how much the debris from deep packaging? I guess that's yours.
I think I'll answer it this way. There was a lot of things that weren't fully accounted for in the early studies when it comes to handling this containerized material. I think we were really more focused on the liquid side of operations. So the debris wouldn't have been accounted to, not to the extent that we see it. And then the other thing, when we relate to the high cost versus the revenue, well beyond maybe what we had anticipated, is we have some costs that we were not planning on ever having, which as an example, the water and resource recovery facility, John here, he pays the city's solid waste division $60,000 a year in rent for use of that recycling bay. Now, that's a cost we never envisioned occurring. So it's some of those types of things that that are driving up our costs that well beyond what we had thought. Fortunately, we're getting adequate tipping revenue to cover that, plus have a net to help defray the capital investment. But yeah, I don't think any of us properly accounted for the residuals.
Yeah. Paula Yinka is a master's student in environmental engineering at Montana State and asks about the biogas. Now, you're flaring the biogas currently. You're not recovering the biogas. Is that the case?
That's correct. Yeah. So the recovered organics are anaerobically digested, and that digestion process produces the biogas. And then we flare it.
You talked about some options for recovering it. Are there any active plans to implement any of that?
There's visions, but we're in search of capital dollars to fully implement to the end destination, which I think the vision right now is to look at cogeneration and microgrids to take advantage of these renewable energy credits for electric power production, which, as John indicated, it's something that EPA has but hasn't issued. So there's a program, but they haven't actually issued any of these credits, and that's what we're anxiously awaiting to see the agency come forward with a viable electric power renewable energy credit.
So are you at least covering the energy demand for the treatment plant or any internal demands?
Well, you could. I mean, you could power the plant with it, but the electricity that we would generate would be more valuable to resell. So we would actually be, if we generated it, we would sell it back to the grid because we would make revenue more than what we could buy it for. With these renewable energy credits, that's kind of how that's going to work. So we probably wouldn't use it to run the plant unless something happened to the outside world. And if the power went out, then we could actually run the plant with the power that we generate. And that's kind of how the microgrid works, is we have enough storage in order to run certain facilities or certain portions of our facility. But generally on a day-to-day basis, we would be selling that back into the market for revenue generation.
So other than the environmental benefit of keeping these organics out of landfills or wherever, what was the benefit to you to undertake this whole operation? You're not recovering the energy from the gas, although you could in the future. So what's the overarching purpose of this with respect to your utility?
Yeah, obviously the revenue generation was key to getting this passed through. And I mean, you can just say it's just an environmental thing to do, but nobody's going to let you spend $3 million just to do that, unfortunately. So the revenue generation was it, and selling the gas is not really just an option. It is something that we are going to do eventually. I mean, you wouldn't do this just to make $150,000 a year. So you really have to have that plan ready to go. It's kind of a chicken egg. Which one do you do first? Do you try to secure, some energy program first and then get the material? And then it doesn't really work that way because nobody wants to do business with you when they don't know. There's no guarantee of gas generation. So we really had to build this first to prove that we did have enough material in the area and that we could produce that amount of gas. And now we're getting calls, and we are in discussion with lots of other companies and entities about how we're going to deal with this gas and maximize our revenue generation from that. It's just kind of a leap of faith is what it really was. That's what it comes down to.
Okay. I think you addressed this. What's the volume of waste material from the recycling center that are sent to a landfill, and what does that cost you?
I'd have to go back and look at the volumes. I try not to think about it because I don't like throwing stuff in the landfills. Obviously, that was my motivation, was to not have things go to the landfill. But I know we spent about $15,000 to $20,000 a year to dispose of that material, which was something else that I kind of thought maybe we could negotiate out with the other city department that we're with. We haven't gotten there yet, so that would help our revenues as well. But I know they got costs as well to do that. So, yeah.
So someone's asked about the number of employees. You mentioned that as 2, right? And someone else asks how do you clean the biogas before selling it, but you don't. So that's just something for the future.
Right.
All right. As ESG adoption accelerated interest in your operation now, so ESG, in other words, is environmental sustainability considerations for the company. I guess the companies that are your clients that you're disposing the waste for. Does that give them maybe bragging rights that they're disposing of their waste in a more environmentally acceptable way?
Absolutely. That's their motivation, straight up. I mean, it costs them more to send it to me than it does to the landfill. So they have to have that kind of motivation behind their operation to do this. Otherwise, it doesn't make any sense to them. But it is beyond just the manufacturer. It's who the manufacturer sells to. They drive that as well. They say, we won't buy this from you if you don't dispose of your waste in a responsible way. So they look for that, and they put that into the cost of their business, and they have to prove that as well. So yeah, there's a lot that goes into who's driving this kind of operation to say, we want this, and this is important to us as a company and to our clients.
Yeah, I'm glad to see that. When you showed those photographs of those piles of waste food and so forth, it makes me sad, actually, because I know about the huge problem we have with food waste, and to think of all the resources that go into waste with that. If we don't at least recover some benefit from that is a shame. Last question I have here is about sludge disposal. I think you mentioned, so I assume it's dewatered. If so, what happens after it's being dewatered?
So yeah, our sludge is sent to a storage pond that's about 2 miles from the treatment plant. It's in the middle of a farm field that rotates corn and soybean. Actually, it's in the middle of about 800 acres of farm field. These raised lagoons or storage ponds, there's 2 of them, 2 6 million gallon lagoons. So we store in one all year, and then we decant water off of that. So we have a floating pump. So as the solids sit in the pond, they settle at the bottom. We decant the water off into the other pond that is next to it. And then that water comes back to the treatment plant. And then in the fall, when the soybeans have come out and the crop is going, or the ground is going to be corn next year, we land apply that. So we have a drag line system where we have hydrants and pipes under the ground, and our tractors hook up to the hydrant and have a drag line hose behind it. And then the tractor has an injection bar, which actually injects that biosolid material into the ground about 8 inches. It's a pretty neat system. It's really easy. It's clean for us. The farmers get it for free. We don't charge them for it because, we don't have dewatering machines. We don't have presses. We don't have centrifuges. We don't have all these other kinds of things. It's a pretty neat and clean system for us to get rid of it.
But you have to, are there regulations about how much you can apply per acre?
Oh yeah. We have to meet agronomic loading rates according to 503 regs from EPA. So yeah, those are well established. Now we do have space there as well, which is good because obviously the nitrogen limits and phosphorus loading to this material has gone up. So they are getting more per acre loading to the ground, but we do still have some room there. So as more material comes in, we have to be cognizant of that, either find more land to apply this to, or we have to figure out something else to do with the solids. But there's a lot more land around that area that we are not applying to. So we should have some capacity that if we needed to thin that out a little bit, so we stay under the agronomic rate, we could do that.
I think you also mentioned this, but maybe you could just remind us, how do your tipping fees compare to landfill tipping fees?
our landfill tipping fees in Muscatine are $45 a ton. They're as cheap as $25 a ton, about 30 miles away from us. And there are places where it's $65 a ton. But across the river, it's like $10 a ton. So yeah, there's a lot of options for people of what to do with this material. So the fact that they bring it to us and are willing to pay $45, $50 a ton is pretty good.
And the last question that we have here is opens a can of worms. Have you measured PFAS content in the co-digested sludge? And
No
I
comment.
would explain that to, yeah. And and for that matter, ensuring that that there aren't other industrial chemicals in there.
Yeah, we are not required at this time to test for PFAS. We have done that, and we have not found. We've been under the detectable limit for PFAS in our biosolids. That's just so our farmers have peace of mind that this isn't doing that. Really, the organic, the food waste that we get is not going to contain that particularly. That we don't think. So we haven't seen it in our biosolids at all.
Great, thank you. And the last Q&A is simply a thank you. So I'll echo that. This has been really fascinating for me. I do a lot of work related to pollution and agronomy. So the connection with that is something that I appreciate.
Sure.
So Jay and John, thank you so much for your presentation. I think at this point I turn it back to Marisa. She has some
Yes, that's
concluding.
right. Yes, thank you so much, everyone, for all your questions. And thank you both, John and Jay, for sharing your knowledge with us today. If anyone would like to reach out to them directly, please feel free. John and Jay, if you can just type in your email address into the chat, that would be great. We do now have an added feature to our webinars we're trying out. It's called an after party. Both speakers have agreed to stick around for a few minutes to answer any additional questions you may have. We'll end our event and we'll stop recording, but if you want to stick around for a minute, you'll have the opportunity to ask some more questions in a smaller group, and you can maybe even put your camera on. And ask those questions verbally. Yes.
Marisa, one person did ask, will slides be posted or the presentation made available?
Yes, I will be sending out a link to the recording, and then the slides will be available on our website probably tomorrow or later in the week.
Terrific, thank you.
And a few more items to mention. We have several webinars planned in the near future, so you can go to aaees.org/events to check them out and register. And if you're interested in sponsoring an upcoming webinar, please reach out to me directly. My email address is mwaterman@aaees.org. Just a reminder, if you're not yet an AAES member and you're considering joining the Academy, please email me to discuss our membership options. And last but not least, I know everyone's wondering, the PDH certificates for this event will be sent out shortly. That's all for today. Again, if you'd like to stay for the after party, please do. And thank you so much. Have a great day. And thanks again to Stanley for sponsoring this event. Bye-bye, everyone.
So that's